So nomenclature is a fancy word for naming chemical compounds. And in this course, we're going to be looking at three main types of chemical categories and learning how to name them. And the first important thing you've got to be able to do is be able to determine which category a particular compound belongs to. And then you'll know what rules to follow. So ionic compounds are a particular category that follow certain naming rules, and they are made up of ions. And typically those ions come from metals, which are the cations, and nonmetals, which are the anion. In this course, if you see a metal in a compound, you can be sure that it is an ionic compound. Now, one thing to look out for is ammonium is also a cation, and it's not a metal. If a compound begins with NH4, then it is an ionic compound because NH4 would be the cation. And anions could also be polyatomic ions. So you want to be really familiar with your polyatomic ions and what their formulas are so you can recognize them in a chemical formula. The next type of compound are known as binary molecular, and these are made of two different nonmetal elements. And then we're also going to look at naming acids. And acids have the ability to form H plus when they dissolve in water. And to kind of put an emphasis on that H, most acid formulas begin with that H. So that's how we're going to recognize acids. The formula will begin with an H. There's a whole nother set of chemical compounds that are known as organic compounds. And there are thousands of chemical compounds in this class. It's very, very important, but it's beyond, most of these compounds are beyond the reach of this class. They're usually specific classes just on organic chemistry, and they spend a lot of time looking at nomenclature. All right, so getting back to this class, let's look at ionic nomenclature. It's pretty straightforward. When we name an ionic compound, the cation name comes first and then the anion. So all we have to do is know what the cation name is and know what the anion name is. So let's look at cations first because they come first in the chemical formula. There are two types of cations. There are cations whose charges are always, always, always the same. Can't really get my box around that, but that's what are known as non-variable charge. Their charge is always the same. And these cations have the same name as their element. So if we take a look at a periodic table and we look here at the alkali metals always have a charge of +1. Always, 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 always. So their charge is non-variable. So if we have a cation, that is potassium, we know not only that its formula is going to be a +1 charge, but its name is going to be potassium. Here, this example of sodium, we see the +1 charge, and the name of this cation is sodium, the same as its element. Alkaline earth elements always have a +2 charge. Okay, so the second column always have a +2 charge, so a non-variable charge. So here, an example of an alkaline earth cation is calcium. It has a +2 charge, and its name is calcium. Its charge is always +2. Three other cations that you must know are aluminum, zinc, and silver. They have +3, +2, and +1. If we look at our periodic table, here's aluminum +3, zinc +2, and silver +1. All other metals, so all the other metals on the periodic table, so everything that is transition metal, these other main group metals, to the right of the transition metals, all of these metals we're going to consider to have a variable charge. And what that means is those metals have at least two other charges that they could have. And it's very important that we know what their charges are because the different charges mean they have different number of electrons and they have very, very different chemical and physical properties. For example, iron +2 and iron +3 have different colors, they react differently, they are very different chemicals. So how do we name the cations of these other metals? Well, the charge is just part of their name. So this cation, iron +2, is written iron 2. Now, there are a couple things I want to point out. 1, the 2, the charge, is written as a Roman numeral. The charge also does not include a positive charge. Metals are always positive charge, so we know that they're going to be positive. Notice also that there is not a space between the elemental name and the parentheses that have the charge in it, and that the elemental name, or the name of the cation, is not capitalized. Names of cations and chemical compounds are not proper nouns. They are not capitalized unless they are beginning a sentence. So over here we have iron plus 3, that cation. The name of that cation is iron 3. The charge in parentheses, those parentheses right next to the elemental name, and the Roman numerals indicate the charge. So that is so important. When you are naming a cation with a variable charge, its charge is expressed as a Roman numeral in parentheses after the elemental name. So how do you know if an element is going to have, if a metal is going to have a variable charge or not? Well, it's not one of these. If it's not an alkali metal, if it's not an alkaline earth, and it's not one of these three, aluminum, zinc, and silver, then it is not going to have the same charge all the time, and it will have a variable charge. So when you look at an ionic compound, first, does it have a metal? If it does, it's ionic. Then you've got to recognize whether that metal cation has a variable charge or non-variable. Non-variable are alkali metals, alkaline earth, aluminum, zinc, and silver. Everything else has a variable charge, and we've got to write that charge down as a Roman numeral. Okay, so that's the cations. Let's look at anions. Anions never change their charges, so they are a little bit more straightforward than the cations. There are two types of anions, monoatomic and polyatomic. The monoatomic anions are based on elements, and their root name is the same as the element, and they end in "ide." So fluoride, bromide, and oxide and sulfide. And their charges can be determined by looking at the periodic table, depending on how many columns they are from the noble gases. So the halogens, one column away from noble gases, they have -1. Oxygen family, two columns away from the noble gases, -2. Nitrogen and phosphorus, -3. Now those are unlikely. It's really hard to hold on to 3 extra electrons, but we can use the periodic table, to give us a clue as to what those charges are going to be. Now polyatomic anions, you've got to know these. You've got to know the formulas. You've got to know their charges. They are going to end either in "ate," in "ite," or in "ide." Okay, so now let's look at naming some ionic compounds. Here we have CuI. I know it's ionic because it begins with a metal, and I know that it's going to be copper iodide. I know that part. Here's my anion. Now, I also know that it is going to have a variable charge. So I've got to figure out what the charge of my copper is. So let me just cut this out for a minute so I can do some math here. So I know my iodide has a charge of -1. There's 1 iodide here, so my copper has to have a charge of +1 to cancel that out. So the name of this compound is going to be copper 1 iodide. Now it's not copper 1 because there's 1 copper in the formula. It's copper 1 because the charge of my copper is +1. Now let's look at this compound. Again, we have copper, and instead of iodide, I now have sulfide. Now sulfide always has a charge of -2. So my copper has to have a charge of +2 to cancel that out. So the name of this cation is copper 2. And how do I know that? Because that's the charge. Why does that have to be the charge? Because it's the only charge that's going to cancel out this -2 from this sulfide. So the name of this compound is copper 2 sulfide. Notice there's not a 2 anywhere in the formula. This 2 is the charge of the copper. Next, let's look at this compound. I have iron, which has a variable charge because it's not alkali metal, alkaline earth, and I have 3 oxides. Each oxide has a charge of -2. So if I have 3 of them, I know that my overall charge due to my anions is -6. So that means my total charge to the irons has to be +6. Has to be +6. So each iron must have a charge of 3. That's the only way I can cancel out that -6 from the 3 oxides. So this name is iron 3 oxide. Over here, I know that I have iron and sulfate. Sulfate always has a charge of -2, so iron has to have a charge of +2 to cancel this out. The name of this compound is iron 2 sulfate. Notice that there is not a 2 anywhere in the formula. This 2 has nothing to do with the subscripts. It is the charge of the cation. And how did I figure out that charge? It is the charge that cancels out the negative charge due to the anion.